There are many situations where there is more than one force acting on an object. And when there's more than one force acting on an object, we need to try and decide whether these forces are balanced or not. So the little diagram I've drawn at the top is an example of a balanced force diagram. There is an object, the blue box, and it's experiencing a force to the right of 5 newtons and a force to the left of 5 newtons. Now this is a balanced force diagram because the two forces act in opposite directions but of equal size, which means they cancel each other out. The overall effect will be zero. If that was a tug of war, you could appreciate that if you pull to the left with 5 and the other team pulls to the right with 5, you're not going to move. Now balanced forces, if an object isn't moving, it will remain at rest. If an object is moving, it will continue to move with the speed that it has. Now the first example is straightforward. 5 newtons to the right, 5 newtons to the left, balanced. However, there's sometimes more than two forces acting on an object. This time I've represented them by the 3 arrows, 5 newtons to the right, but this time to the left there are two forces acting, and I've told you that one of them is 2 newtons. What must the value of the missing force be so that this situation is still classed as a balanced force? Hopefully said 3 newtons. 5 newtons to the right, you need 5 newtons to the left. There happens to be two forces. If one of them is 2 newtons, the other one must be 3 to make sure that you're 5 left and 5 right and still balanced. Unbalanced forces is obviously when the forces aren't balanced. And a very straightforward example I've drawn on the board demonstrates that. Still get 5 newtons to the left, but this time is only 3 newtons. Sorry, 5 newtons to the right, this time is only 3 newtons to the left. These two forces are clearly not balanced. Now if these two forces acted on an object that was stationary, then it would start to move. And it would start to move to the right, in the direction of the bigger force. If it was already moving, then it would cause its speed to increase. It would start to accelerate. And finally, when we do appreciate that forces are unbalanced, we have to be able to calculate what's known as the resultant force. So in other words, take into consideration all forces that are acting either left to right or up and down. Take them all into consideration and rewrite the diagram with only one force. Now from the previous unbalanced board, with 5 newtons to the right, 3 newtons to the left. This can be rewritten as 2 newtons to the right. In other words, 5 take away 3. You take the larger of the forces, subtract the smaller, and that gives you the size of the resultant force, and the direction is in the same direction as the bigger of the two forces. Now another little example. I've sketched there. 6 newtons to the right and 3 newtons to the right, but only 4 newtons to the left. This is also unbalanced, but it's calculating the resultant force, which is important. If you look to the right, you've not only got 6, but you get 6 plus 3, that gives you 9. You've got 9 newtons to the right and only 4 to the left. have once again 5 newtons to the right, and that is the resultant force.